today we will discuss about random forest, which is a SQL algorithm, the decision tree algorithm. Okay. So, what exactly random forest is? The name itself indicates that it's a forest. Okay. So today we have discussed about decision trees, right? So, like that, uh, how we develop a decision tree. Here we are going to create multiple decision trees. So, how a forest will be formed? Forest is nothing but a group of trees, right? Multiple number of trees together form a forest. So, similarly, here what we are going to do is we are going to implement multiple decision trees. So, these multiple decision trees all together form a random forest. So, basically, it's a ensemble algorithm. It's a kind of ensemble algorithm. Ensemble algorithm, nothing but it's a group of multiple algorithms. So, uh, so since we are developing many decision trees, logic is simple. How we are going to do is first we consider the data, and from the data we are going to sample the data into different training points. So multiple data points will be formed. I mean, multiple training data points will be formed randomly. Like, let's say, for example, you have 100 observations. So out of these 100 observations, we are going to split into multiple random samples. Sample is nothing but again group of observations. Okay. Yesterday I have explained you, right. If you are having a population of data, from that population of data, we are making it some samples out of the entire population. So the random sampling of the data points will be done automatically by the algorithm, right? So if you're having 100 observations, I'm going to create random samples. Those random samples can be having 5 parts, means each one having let's say or let's say 10 samples, each one having 10 observations, right? So it can be done by the algorithm itself. No. Here we are developing a random forest algorithm. We have a separate random forest algorithm. The algorithm is nothing but model in such a way that it segregates all the decision trees within the function, right? If you if you wants to go through the points, you can go through them. So basically, we will be sampling the data first. Then after that, we will be selecting the features randomly. Again, the selection of features will happen randomly. So the main difference between the random forest and the decision tree algorithm is that uh, finding of the root node. Selection of the features will be happening randomly in random forest. Okay. Yeah, exactly. So basically, technically, it's a ensembling algorithm. Okay? Since we are making n number of trees, so this n number of trees together we are calling it as a forest. So the basically the attribute selection will happen based on the parameters such as information gain ratio, Gini index. Yes, yes. For every sample, we will be creating decision tree for each and every sample. So all the decision trees, whether we are calling it as a random forest. So for each decision tree, we will be calculating the information gain, Gini index, and everything. So based on these parameters, we will be finalizing the attribute.
So this the logic that we saw yesterday for kind of like
decision trees.
Gini index and then one more parameter. What was that he calculated? Like which
Variance.
decides the which path needs to be going.
Yes. Chi-square example. Chi-square, Gini index, information gain. So these parameters will help us in choosing the best feature out of the total features we are having.
Okay, got it.
Right. So what happens here is, basically in this classification problems, basically in decision trees and random trees, what happens is we will implement multiple number of trees, and each tree will votes the particular class label, right? So for example, if you look at the slide, here I have attached a figure to make you understand. Here I'm having some 6 trees. Okay. So
Okay.
from the trees, the first decision tree I have predicted 1. The second decision tree I have predicted 0,
Mm-hmm.
and 1, 1, 1, 0, and next 1, 1, 0. So I have make it. I mean, I have done some predictions for each and every individual decision tree.
Mm-hmm.
So each individual decision tree makes a vote for a particular class label.
Mm-hmm.
So from this, I have total 6 1s and 3 zeros.
Okay.
So with this, I can say that my random forest. So now this is a bunch of trees, and I can call this as a random forest.
Mm-hmm.
So what happens in this classification problem is we will consider the most popular class label which is predicted.
Most popular class label which is predicted.
Yeah,
What would that mean?
yeah, you can understand the point from here. So each tree depends on a independent random sample.
Mm-hmm.
Right?
Correct.
Each and every independent decision tree we have considered or built will depend on that random sample, independent random sample on which it got developed.
Correct.
So for that random sample, this particular random decision tree will gives a prediction of 1,
Okay.
and another set of random sample, second decision tree is going to predict 0.
Okay.
Like that, we have multiple random samples. For each and every random sample, we are going to develop a decision tree algorithm on each and every sample. So
Okay.
now here, random sample which we created is independent of other. Everything is unique to that particular
Three.
decision tree.
Okay.
Right? So there is no dependency on another decision tree, and there is no dependency on another data sample which we created.
Yeah.
So
Got it.
this is how we develop the decision trees, and all these trees together we call it as random forest. So what I'm saying is, for each and every decision tree we have a unique predictions.
Okay.
So in classification problems, what happens is we will consider the most popular class that is predicted, and we considering it as the final result.
Okay.
So here we have 6 1s and
Hmm.
3 zeros.
Hmm.
So for decision tree, our random forest algorithm will considers the final output as 1.
Hmm. Got it.
You got my point?
Yeah.
So to contrast, I mean, in a contrast to these classification problems, what happens in regression algorithms is like linear regression or logistic regression or multiple linear regression, some other regression problems. What happens is they will take the average of all the outputs.
Okay.
So what happens then? There are 6 1s and 3 zeros, right?
Correct.
So it takes an average of all the things and it gives a aggregate.
Okay.
So in that case, that is, I mean, that may not be the appropriate one, right?
Mm-hmm. Why it won't be appropriate? Because that would be the maximum of
Okay.
all the decision trees, right?
No. They, what we will be doing, we are taking the average of all the outputs, right?
Hmm.
Considering the, I mean, taking the average is not the good idea in
Ah, correct. Correct.
statistically,
Correct. Correct.
right?
Absolutely. Yes.
You're averaging the more
Yeah.
dominant.
One decision tree three may have higher value, one may have lower value. So averaging out would dilute it.
Right.
Okay.
So let's look at the pseudocode, like how the random forest algorithm will be implemented.
Okay.
So first we will select the a number of features out of total number of features. Let's say if I'm having number of features in my data, so out of these 10 features, I'm going to choose k features.
Okay.
Okay, which is less than m.
Okay.
So among these k features, I'm going to calculate the node p
Hmm.
using the best split point. Again, what I'm going to do is split the node to the daughter nodes using the again best split mode.
Okay.
So for each and every node, again I'm trying to split into daughter
Best
nodes,
less.
I mean child nodes.
Okay.
Next, what I'm going to do is I'm going to do the same step from A to C until reach the maximum number of nodes.
Okay.
I mean, so that there is no other further splitting of the nodes happens.
Correct.
Then we'll be developing the forest, or I mean, we will finally end up building a forest with a number of trees.
Okay.
So after developing this random forest, I mean now we have developed the forest by splitting into a number of nodes. Now
Hmm.
what we are going to do is on this forest we are going to implement the algorithm. That means we are going to fit the algorithm and try to make the predictions. And from that predictions we are calculating the maximum number of votes which we have picked. So the maximum number of predictions which got the maximum votes, we are considering it as our final.
Hello. Hello.
Hello.
Yeah, you're right. As I lost your voice. As final.
So yeah, so out of the maximum votes we have predicted, we are considering that as our final prediction.
Okay.
You understood the logic,
Yeah.
right? If you look at the applications of random forest algorithm, um, the major problem in building machine learning algorithms is overfitting and underfitting.
Okay.
So, what exactly overfitting and underfitting is? I think I have explained you some time ago. Do you remember?
Yeah, I do remember it.
Yeah. So, what happens in overfitting? So, my algorithm trains more and it gets accuracy of 95 and above,
Five.
which is yeah 95 and above.
Yeah.
Like the accuracy which is getting 95 and above is not at all acceptable.
Correct.
Why? Because accuracy indicates that my model is overfitted. It means the data is very pure.
Hmm. Correct.
So and underfitting is another problem, that we will be getting an accuracy of less than 50%.
Correct.
So we should not encounter such kind of problems while developing the algorithm.
Correct.
So the best accuracy which is acceptable is some 80 to 90. Yeah, even 70 to 90 is also acceptable. So and another important, so what is the advantage of this random forest is this will avoid the overfitting problem.
Okay.
Why? Because how it is going to avoid is we will be splitting the
Splitting the
samples,
data.
right? We
Yeah.
are not
Correct.
right. We are splitting the data into n number of random samples.
Yes. So every
So
data, like
we
all good
don't.
data, is not a part of one
Yes,
explicit set.
exactly. In earlier algorithms, what we have done, we have considered the entire set of data and we just split it into 70 into 30 ratio
Correct.
and we trained and tested. But
Correct.
here, the algorithm, while developing, while training, the splitting of entire data into random samples will take place.
Hmm.
So there is no point in having overfitting problem.
Mm-hmm. Correct. Got it.
Right. The other advantage of random forest algorithm is we can make use of this algorithm for both classification problems and regression problems.
Oh, okay.
Okay.
Yeah.
Another important problem is that we can identify the most important features from the training data.
Okay.
That is nothing but our feature engineering.
Correct.
One of the algorithm feature engineering, like we will be developing in coming sessions, is principal component analysis.
Okay.
It is a unique algorithm for identifying the most important features. But here, this random forest also has ability to, you know, identify the most important features of the data.
Yeah.
Okay, we will get back to the algorithm. So I want you to open the Jupyter notebook.
Okay.